Assalamualaikum everyone, myself Mudassir Masood, registration number 21T60. So today our lab of DSP is lab number 10, which is frequency sampling design method. And the objective of this lab is to implementation of FIR filter using frequency sampling method. Here is the theory. Frequency sampling method, in addition to methods of Fourier transform design and Fourier transform with windowing discussed in the previous section, frequency sampling is another alternative. The key feature of frequency sampling is that the filter coefficients can be calculated based on the specified magnitudes of the desired filter frequency response uniformly sampled in the frequency domain. Hence, it has design flexibility. Here is the task number 1. We have to implement in this in MATLAB. Design a linear phase low pass FIR filter with 25 coefficients using the frequency sampling method. Let the cutoff frequency be 2000 Hz and assume a sampling frequency of 8000 Hz. Part B, plot the magnitude and phase frequency responses, and part C is list FIR filter coefficients. And here is the MATLAB code for this task. We define sampling frequency fs at 1000 Hz, which is given in the problem, and we define magnitude specifications for the filter and the design filter FIR filter, one with 25 coefficients using frequency sampling. Here n is the number of filter coefficients, and then we calculate magnitude frequency response for the filter 1, and then we define magnitude specification for filter 2, and then design FIR filter 2 with 25 coefficient using frequency sampling, and then calculate magnitude frequency response for filter 2, and then here is plotting figure. We plot magnitude response for filter 1 and filter 2, and then plot phase response for filter 1 and filter 2. Here is the output of this code. So the next task for this lab is task number 2, and we have to design a linear phase bandpass FIR filter with 25 coefficients using the frequency sampling method. Let the lower and upper cutoff frequencies be 1000 and 3000 Hz respectively, and assume a sampling frequency of 8000 Hz. In part B, list the FIR filter coefficients, and in part C, plot the frequency responses. Here is the MATLAB code for this task. We define sampling frequency, and then we define magnitude specifications for filter 1 as previous, and then here we at the end we plot magnitude response for filter 1 and filter 2, and plot phase response for filter 1 and filter 2, and this is the output of the task.